All right, we're going to convert this time from polar into rectangular, but we're basically going to use a similar process. Still construct a triangle with the first side along the x-axis, the second side parallel to the y-axis, and a third terminal side connecting the origin. So we're just making a right triangle in quadrant 1 that is x comma y. And then this is theta and this is r. And if this is 0, 0, right, the trig ratio that we can think about is that the cosine of theta, cosine is adjacent over hypotenuse, isn't cosine x over r in this right triangle, right? Because for any right triangle, the cosine relationship is always adjacent over hypotenuse. Well, the sine value is always opposite over hypotenuse. So these two trigonometric relationships, I'm just grabbing from this right triangle on our graph. So if you forget the polar, conversion, just redraw for yourself that triangle and just think about cosine and sine. And so it says by solving the first equation for just x by itself, all you have to do is basically multiply this r that's in the denominator to the other side. See how you'd get r cosine theta? So x, to get the x coordinate, you're going to take your r value and multiply by the cosine of the angle. Same thing over here. To get y by itself, you're just going to multiply r to the other side. So the y coordinate is r times the sine of the angle. Well, you need to know the cosine and sine of your angles. That's what tomorrow's quiz is about, to make sure you know those values. So these are the conversion factors to go from polar into rectangular. So you're no longer using Pythagorean theorem and tan inverse. Now you're using the cosine and the sine of the angle times the r value. So example 12, let's change 2 comma 30 degrees to rectangular form. I'm just going to do 2 cosine of 30 and 2 sine of 30, and I'll have my coordinates. So you have to know that the cosine of 30 is root 3 over 2 pretty quickly. That shouldn't be the hard part. So we've got 2 times root 3 over 2, and that's just root 3, isn't it? So my x coordinate is root 3. Now I'm going to solve for my y coordinate. I should have left myself some space here. 2 times the sine of 30, well, the sine of 30 is a half, right? So 2 times 1/2 is 1. So my x and y coordinate is root 3 as a distance, which is about 1.7, comma 1. So to get to, if this is 30 degrees, here's 2 comma 30, that's the same as going over 1.7 on my x-axis and up 1 on my y-axis. Where did I just draw that? Oh, here it is. So over 1.7 and up 1 is the same as going 30 degrees and 2 as the r value. So that's it. That's the conversion factor. So I said, but example 13, if you wanted to change this polar coordinate to rectangular form, I wouldn't use the formula. This is a quadrantal angle. So what I would do is plot your quadrantal angle. Oh, so -10, it says, remember what a negative r value does. I would go to pi over 2, which is 90, but I'm going to walk 10 in the opposite direction. So I'm actually down here. I know that xy coordinate. I don't have to multiply by cosine theta times r. That's just 0, -10, isn't it? So don't overthink it. If it's a quadrantal angle, you should be able to write all quadrantal angles x comma y without using the formula. So number 14 is a quadrantal angle, right? I'm at 2 and I'm at 360 degrees. So I'm right here. I know how to write that x comma y, right? That's just 2 comma 0, x comma y. Didn't have to multiply by r cosine theta. -460 though, that fits perfectly into doing r times the cosine of the angle and r times the sine of the angle. So you should know that what the cosine of 60 is. That's what I want you to practice so that this part can be computed in your head. Cosine of 60 would just be 1/2, right? Because sine of 30 is 1/2 and cosine of 60 is 1/2. They're, what was that called? Not cofunctions. Oh, complementary angles, right? So -4 times 1/2 is just -2. And the other one would be √3/2. Sine of 60 is √3/2. So if I wanted to reduce that, I could cancel my 2's, right? 4/2 would just be 2/1. So -2√3. Number 16, you have to do on your calculator. So why don't you type number 16 into your calculator? 1/2 times the cosine of 80, 1/2 times the sine of 80, and then just, round to like 1 decimal place or something. So take a minute, make sure you're in degree mode. Type in 1/2 cosine of 80, 1/2 sine of 80, and 1.48. Does that sound like what you got? All right, so for this last bit, I'd like you to try this back page. So you're going to be plotting some polar coordinates yourself, converting into polar, and then converting into rectangular. Make sure for the quadrantal angles, you just do them very quickly. Don't do the long process. You should do quadrantal angles without needing the formulas.